In our calculator, we get this really long irrational number. This is a case of those irrational numbers we talked about earlier this year. And we would like to simplify that, but we don't want to have to estimate. So we're going to follow 3 simple steps. Write these down. Step 1, find a perfect square factor. Remember the days of factor trees? We're going to do some factor trees. We're going to rewrite this radical. The radical is the symbol, the square root symbol. It's called a radical sign. We're going to rewrite it as a multiplication, again using the idea of factoring. And then lastly, we're going to simplify that. This is just like when you simplify a fraction. You're not changing the value. You're just putting it in easier numbers to work with. So the first thing we want to do is remind ourselves what perfect squares are. So I'm going to say a problem. You're going to give me a number, and the number you give me is the perfect square, right? 1 squared.
1.
That's the smallest and first perfect square. 2 squared?
4.
3 squared?
9.
4 squared?
15.
5 squared?
25.
A couple more. 6 squared? And 7 squared.
49.
All right, so you should kind of just have these numbers running through your mind when you're looking at simplifying radicals. So I take the square root of 27 and I ask myself, is there a perfect square that is a factor of 27? A factor. 9. 9 times what gives me 27? Okay, so we're going to rewrite that as the square root of 9 times the square root of 3. Well, why do we do that? Because the square root of 9 is simplifiable. What is the square root of 9? 3. This is the simplified version of the square root of 27. It's simplified, again, just like we simplify fractions. It just puts it in smaller terms. It's not changing the meaning of it. If you want to verify that, you can type this in your calculator. Type 3 times the square root of 3 in your calculator, and you'll see they're exactly the same. It's just a simplified version of that.
Is that like cubing it?
Cubing is to the 3rd power.
Yeah.
And you can do this with cube roots the same way. I think when you watch your video with Saul, he does an example with that with cube roots as well. But it's just taking it and from numbers that are larger and reducing it to numbers that are smaller. Easier to work with. The one we had a couple minutes ago, the square root of 52. Are there any perfect squares that go into 52? 4 does. So we think of a factor tree. 4 times 13 is 52. What's the square root of 4? 2. And so that would simplify to 2 times the square root of 13. Now, a lot of times we just like the decimal value, and that's appropriate for the problem. But in geometry, sometimes you'll see these problems, and they'll say give an exact value. If I type this in my calculator, I'm going to get a decimal. But if I write it like this, this is still an exact value, and it's in simplified form. You'll practice this a little bit more in geometry, and you practice it a lot in algebra too. Let's do one more example. Square root of 98. What goes into 98 off of our list?
6? No, 6.
6 is not on my list.
49.
36. 2 and 49 go in. Now, 2 is not a perfect square, but 49 is. 49 times 2 is equal to how much? 98. Again, it's a factor tree. What's the square root of 49? 7. And so this is the simplified version. And it's always easy to check because you grab your calculator and see if you get the same decimal values. One of your online quizzes is simplifying radicals, so you'll get to practice this. And you can use the hint to help on those first few. But I would just jot those down at the top of your paper because those are the numbers you're going to be looking for. Here's another example. Sometimes I'll see the square root of 20 and people will say, well, 10 times 2. Yeah, 10 times 2 does give you 20, but does the square root of 10 simplify?
No.
Does the square root of 2 simplify?
No.
So that doesn't help me at all. But there is a perfect square that goes into 20. Which one
4.
is it? 4. 4 times what?
5.
So the square root of 4 is 2, and the 5 just stays like it was. Okay? Zach, do you have a question or you just start to explain?
I think let's see. Like we get 3 and the square root of 3. Is that like just times it? Or?
Yes. Yeah, that means times. Just like when you have a number next to a variable.
Oh,
it means yeah, exactly. You know, they got to leave out those symbols. All right, so in the 3 videos you're watching, you're going to, or the 3 skills you're practicing, one of them is simplifying square roots, and then the other 2 are both Pythagorean theorem. then all those videos that you're going to be watching are leading into what we call permutations and combinations. And again, we'll do some practice problems together with that on Friday. You have a few minutes to work, and you'll have the whole hour tomorrow